Hi everyone, get amped up because today we're talking all about energy. Energy is the ability to do work. It's anything that can make matter move or change. But to talk about this, we have to know what work is. Work is the use of force to move an object. The amount of work done depends on the amount of force exerted and the distance the object travels. So if we were going to put this in a math equation, we would say that work is force times distance. What's important is that just because you are tired because you're doing something doesn't mean that work is being done on the object. So the example here is that just because you're holding a suitcase doesn't mean that there's work, because the force that you are putting on the suitcase isn't causing the suitcase itself to move. And so for there to be work, the force has to be causing the motion to happen. Otherwise, there's no work. So in this example, there's no work happening here because the girl is moving. There's still a force, so there's a movement happening, but the direction that the bag is moving is not caused by the force, which is her walking. In this situation, she's picking up the bag, and that's the force is going up, and the bag is also moving up, and so that is work. Also important to know is that energy can never be created or destroyed. It can only change from one form to another. That's something Albert Einstein discovered. This in science is a really important thing called the law of conservation of energy. So hopefully you know that conservation means to save. If you're conserving, you're saving water, or food or anything else, or energy. And so this just means that energy can change forms, but it's never created and it's never destroyed. So all of the energy that's on Earth when Earth began is still here, it's just in a different form. Here's some examples of how energy can change forms. So in the first example, the ice cream is getting changed into the energy that a person needs to ride a bike. The sun is getting changed into food for the tree through photosynthesis. Similar situations. Another example is that, let's say Cam Newton eats this Big Mac, which Cam Newton probably doesn't eat very many Big Macs, but let's say that he does. That food that he eats is transferred into the energy that he needs to score a lot of touchdowns, and that's mechanical energy. So same thing for you. This is happening all the time in your body and outside your body and all around you, all over Earth. Today we're going to talk specifically about mechanical energy, which is the energy of motion. There are two types of mechanical energy, and they're both really important and they work together. And those are potential energy, which is the energy of position, and kinetic energy, which is the energy of moving things. We're going to talk about an example of a roller coaster. So this is a lovely roller coaster. The beginning is over here. And the reason that the first hill on roller coasters is usually the highest is that throughout the ride of the roller coaster, energy is being released into the environment. And that energy is in the form of heat. And what's causing this heat to be released is the friction that's happening between the wheels and the track. So lots of friction on a roller coaster. Because of this, if the second hill is too high, such as this one, then it's possible that the car won't actually make it over the hill and will slide backwards. And that's because the energy that the car has at the beginning, over here, is much greater than the energy that the car has over here at the end. So here's an example. The first hill is usually the highest, and that's because engineers know that the roller coaster won't have enough energy to make it over big hills later on. And the higher this first hill is, the more potential energy that the roller coaster will have. Potential energy is really good because if you don't have enough potential energy, then the roller coaster won't move. There's nothing to convert into anything else. So here's a great diagram that's showing how potential energy and kinetic energy increase. Once the roller coaster gets to the top of the first hill, it has the greatest amount of potential energy that it's ever going to have. That's this yellow car. Once it starts moving down the hill, the potential energy decreases and the kinetic energy, the energy of motion, increases. And they work in pairs. So this one goes down the same amount, this one goes up. Same thing would happen later on. If the car started to go up another hill, then you would see potential energy starting to increase like you do in this orange situation, and kinetic energy decreasing. And then when it went back down the other hill, you would see that kinetic energy increases again. So you can see here that first hill is the highest so that the car has enough energy to make this loop later on, because keep in mind, all this time, heat is being released. So there's two things that are really important for kinetic energy, and they are the speed and the mass. So they directly impact how much kinetic energy an object has. Here's an example where there's a small ball and a larger one. And they both have, at this point, the same amount of potential energy because they're sitting on the table together. But they actually are going to have different amounts of kinetic energy, and that's because this ball has a much larger mass than the smaller one. And so there's more kinetic energy here. Same thing with the roller coaster. The speed is dependent on how tall the first hill is, and that's why you'll see really tall first hills, because the faster the roller coaster is going, the more potential energy there is. Similarly, if you have a full roller coaster car, there's going to be more kinetic energy because the car will weigh more than if it was empty. Here's a great diagram that's showing some different ways that energy can be transferred from one form to another. So mechanical energy is transferred to thermal energy or heat through friction, like we talked about on the roller coaster. Here's a good one that you use a lot when you charge your phone. So chemical energy is transferred to electrical energy when you charge your battery, and then back the other way when you use your battery. So all the time, energy is changing. All right, thanks for watching. Thanks for learning about work. Don't forget to do your discussion post, and we'll see you back next week. Bye.